Hello everyone, I am Tahira Mazumdar from IT department, Ajay Kumar Garg Engineering College. Today I'll be talking on the topic of key management, and I'll be talking more about KERBEROS service which handles key management. And this topic comes under cryptography and network security with subject code KCS 074 under AKTU University. So I'll be talking basically in this today's lecture. I'll be talking about what exactly key management is, what are some of the issues related to key management, and then I'll be talking more in detail about how KERBEROS works, which deals with key management. Okay, to start with, first I'll talk about what symmetric key distribution is as I proceed further. Symmetric key distribution, we all know, as I told in my previous class, that symmetric key management basically deals with single key, single shared key, and asymmetric key management deals with two keys, which involves private key and public key. So basically, in case of key management, we'll be focusing on symmetric key management, where a single key is being used at the senders and at the receivers end for encryption as well as decryption. So, so for symmetric cryptography, we need a single shared key by both the parties. By both the parties, we mean the sender and the receiver. So here we can say that if Alice wants to exchange messages with n people in the network, then she will obviously need n different symmetric keys. Fine. And then, but if n people need to communicate, now if for Alice, she needs n different n symmetric keys or n shared keys, because we are assuming that there are n people in the network. So if each of these n people again want to communicate with each other, then we can say we need a total of n into n minus 1 by 2 keys. Why so? Because we are assuming a single key is used in both the directions of communication between a pair of people. So we call it as, this is also referred to as n to the power 2 problem. Now the focus in key management is, we know that in case of symmetric key, we need a single shared key. The focus or the challenge is how to distribute the key between the parties who want to communicate. So the distribution of the key is a very important challenge, and key management basically deals on this issue. So we basically need an efficient and reliable method of maintaining and distributing the secret key between the communicating parties, and key management focuses on that. Okay. Now, so before we go into more, so we have this something like, let us just give me a moment. Okay. Now, let us talk about, before I proceed more, let us talk about this particular term called key distribution center. What is this key distribution center and what role does it play? Now, each person basically who wants to communicate with any person, let us say Alice wants to communicate with George, Alice has to do this via a mediator, which we call it as the key distribution center. And what is the role of this mediator or the key distribution center? The role of this mediator is to ensure that both Alice, for example, wants to communicate with Bob, then the role of this key distribution center is to give a key, let us say K, let us say X, to both Alice and Bob, so that Alice can communicate with Bob using X, and vice versa. Bob can communicate with Alice using X, and this X we call it as the session key, which is temporary, Fine. And this, the main role of KDC here is to ensure that any communicating parties who wants to communicate, Alice wants to communicate with Bob, so Alice will share a key which is already fixed between KDC and Alice, which is, let us say, K Alice, and KDC will share a key with Bob, which will let us create K Bob, and the role of this KDC is to give a common session key which will be used for asymmetric encryption and decryption between Alice and Bob, and this session key is temporary. And this is how the whole focus, this is how things proceed when we are talking about key management. So what is key management? Let us just summarize it. Key management is a set of techniques and procedures which supports the establishment and maintenance of keying relationships between the authorized parties. It means if any two people want to communicate or want to do encryption, want to communicate in a secured way, the first point is, and we are talking about symmetric encryption, the first point is before you go for the encryption algorithm, to know what is the key which you'll be using for the encryption and for the decryption. And key management is basically how to handle the keys, to get the keys, to maintain the keys, and so on. So we can say it is basically a keying relationship. Key management is a keying relationship, and its task is to ensure that the key is being shared, a common temporary shared key is being shared between the sender and the receiver, and that key will be used for subsequent encryption decryption between the communicating parties. So to summarize, we can say, what does key management do? Key management basically includes a set of procedures and techniques which is meant for the purpose of initialization of the system users within a certain domain to generate, distribute, and install keying materials which can be which are shared, we call them as shared session keys, to control the use of the keys, to update, to revoke, and to distract the keys as and when required, to handle the aspect of storage, backing up, and archiving of keying materials. So these are some of the issues which are of concern when we are talking about key management, and today we'll be talking about an example which uses the key management aspect, which is called it as KERBEROS. So before with that, we'll just talk about something about some facts, features about key management, about KDC. KDC is what we call it as the key distribution center. So what happens when there are a number of people or number of communicating parties in the network? If the number of parties are very huge in the network, then how to handle the KDC? A single KDC will not serve the purpose. So in that case, we'll be going for multiple KDCs, and how to organize the multiple KDCs. So there are two ways. Either you go for a flat multiple KDC, where, for example, Alice wants to communicate with Bob, and the network is a huge one. So what we do is that we divide the communities into certain domains. For each domain will be having each KDC, and if Alice is in one domain and Bob is in another domain, so Alice will be contacting her KDC, and this KDC will connect with other KDCs, and finally Bob will be reached. So the KDCs can create a secret key between the Alice and Bob in this way. So another way of organizing the KDCs is going for a hierarchical kind of structure. Here we have a tree-like structure of KDCs, and if Alice and Bob, they are two different domains, let us say they are in two different countries, and Alice wants to connect with Bob, so Alice will send a request to the local KDC that it wants to connect with Bob, which is in a different country, or maybe in a different far domain. So what will the local KDC do? The local KDC will subsequently pass on that request to the national KDC, which will again be forwarded to the international KDC, and this will be again forwarded to the national KDC of the receiver. Let us say here we are calling it as Bob, then which will be forwarded to the local KDC of Bob, and finally things will proceed in this way. So this is what happens when we are going for a huge network involving a number of KDCs, and how to handle the KDCs. So we can either go for a flat structure or we can go for a hierarchical structure. Now, the very important point when you're talking about key management is called, we have this point called session key. What is a session key? This is the most important point when you're talking about session key. The session key basically is the secret key that is established between the communicating parties. Because before you do the encryption or the decryption, let us say we are talking about symmetric encryption, in which case you need a single shared key. So before you start with the encryption algorithm or the decryption algorithm, you need to know the key. And so how to establish the key? That key which is being established, we call it as the session key. And for that reason, KDC helps. KDC is the structure, the key distribution center is the unit which helps in the establishment of a single shared key. And this particular shared key, it is temporary in nature. What do you mean by temporary in nature? This single shared key which will be used for encryption and decryption is meant only for that session. The moment that session expires, this key will no more be of use. Hence, we call it as temporary key, temporary session key. So a session symmetric key between two parties are temporary in nature. Why so? Because they are used only once, and this key is being generated with the help of the KDC, which acts like a mediator between the communicating parties. So before we go to KERBEROS, let us just talk about a single protocol where a KDC is used for establishment of the keys. So here Alice basically sends a plain text message to KDC to okay, I'm not reading out this text. I'll just explain it from the figure how exactly the protocol works. So we have this key KA, which is basically an encryption done using Alice, using the key as shared secret key between Alice and KDC. This particular icon is hinting at the session key between Alice and Bob. KB is encryption done with the key that is shared between Bob and KDC, and KDC, we all know it is the key distribution center. Now I'll just explain how exactly KDC is used for the establishment of a session key. Now we have Alice, we have Bob, and the mediator here is the KDC. Alice wants to communicate with Bob. To do the communication, it needs the shared session key. And so what Alice will do, Alice will request to Bob that, Alice will tell to KDC that I want, myself, I'm Alice, and I want to connect with Bob. Now what the KDC does is that KDC now generates the key. What key? KDC generates a session key. This figure is a session key between Alice and Bob, and this message that the communication is to be established between Alice and Bob. And this particular message, KDC, what does it do? It encrypts using Bob, using the key between Bob and KDC. That means this particular message is meant for Bob, to be given to Bob. But what the KDC does is that it does not directly give it to Bob. It is sending to Bob via Alice. How it happens, I'll explain. So in addition to this part, in addition to this message block which is meant for Bob, the KDC also generates the same session key between, which is meant to be used between Alice and Bob, and KDC encrypts the entire thing in totality using the encryption key. What is KA? It is encrypted using the key between Alice and KDC, because Alice and KDC is known only between Alice. The key between Alice and KDC is known only between both of them. So obviously they are using that key for their communication. Now after this message is received in the second step, this is the second step. What does Alice do? In the third step, after this message is received, Alice, what does it do? It decrypts the message because it is encrypted using the key of between Alice and KDC. So obviously that key is known to Alice also. So Alice decrypts it, and after decrypts it, Alice retrieves the session key. Fine, it can get it. Retrieves the session key. What is this? This is a session key between Alice and Bob. Alice retrieves it, and after retrieving this, the remaining block, this is the remaining block. This is the, I'm repeating it again. This is the remaining block which is not legible to Alice. Why it is not legible to Alice? Because it is encrypted using KB. It is encrypted using the key between Bob and KDC. So it will be legible only to Bob, not to Alice. So what Alice does, Alice sends this message block to Bob. Now once Bob gets this message is encrypted using KB. What is KB? KB is encrypted using Bob and KDC key. So obviously Bob can decrypt it because it is a key that is shared between Bob and KDC. So Bob decrypts this message. And on decryption, Bob also gets to know that Bob is supposed to communicate with Alice, and the shared session key is known to Bob as well. So right now, after the completion of the third step, Alice gets to know the shared session key. Bob also gets to know the shared session key, and once the shared session key is known, both of them then can start communicating by doing the encryption and decryption using this particular key. And the point to be noted is that this key is temporary in nature. It is meant only for this session. If it is required for more session, then more times this algorithm has to be executed. This is what I just explained to you. It is now I'll talk about another algorithm which is a very important algorithm, which we call it as KERBEROS. It is also used. It is an algorithm which works on key management and which focuses on establishment of keys. What is KERBEROS? KERBEROS is basically an authentication protocol, and at the same time it is a KDC, and it has become very popular nowadays. Several systems are using KERBEROS, including Windows, and it was originally designed at MIT. In KERBEROS, KERBEROS has separated the process into two parts. The first part is the verification, user verification. This is the first part, and the second part is the issuing of the ticket. So KERBEROS does this, what the process which I just explained right now, the same process KERBEROS does, but it is doing so in two phases. First is verification of the user, the second one is issuing of the tickets. And KERBEROS basically is designed to support client-server communication such as FTP. And let me talk more on KERBEROS now. In case of KERBEROS, 3 servers are involved. Here, KERBEROS basically is a service. It focuses on client-server communication. So here, client does the role of Alice, which I told in the previous algorithm, and server takes the role of Bob. The main server which clients wants to connect, we are calling it as Bob, the real server that clients wants to connect. Now, so other than this server, in case of Kerberos, we need two other server. We call them as authentication server and ticket granting server. What is authentication server? Here, through authentication server, each users, or we can say each client, they register with the authentication server and it is granted a user ID and a password. So whoever wants to connect, they first have to authenticate themselves via the authentication server. So those users, all the clients initially have to be registered with the authentication server through some user ID and password. After that, the ticket granting service starts, that server starts, and this server's role is to give a session key, which we are calling it as a ticket for the server. For the real server here, it is Bob, that means between the client and the server. So the session key or the temporary session key is generated by the ticket granting server, and its role is to provide the session key that will be used between the client and the server. We call it as KAB, meaning A for Alice, which will be the client, B for Bob, which will be the server in this case. Now, let us talk more on this before I take the algorithm. How does it work? We have the client here, and we have to start with, first the client registers itself or authenticates itself via the authentication server through some user ID and password. This is the first step. This is step number 1. So whoever wants to connect with another client wants to connect with server, before that it has to have its email ID. So not email ID, it has to have its user ID and password, and through that it has to first authenticate itself. And for authentication, it takes the use of the authentication server. After the authentication server is being client is being authenticated via the authentication server, the authentication server now tells the client to communicate with the next unit, which is a ticket granting server. So authentication server gives a ticket or a session key to the client to communicate with the next server. This is step number 2. This is step number 1, which I told, and it gives to the client a ticket, via which it will communicate with the ticket granting server. Client, after getting and gives a timestamp for the period for which the communication will be done. And after this, the client then communicates with the ticket granting server, where it requests for session key with the session key, which will be used to connect with Bob or the server. Here the client, let us say we call it as Alice, and the Bob we call it as the main server. So this is step 1, this is step 2. Step 1 for authentication, step 2 for granting of the session key. Step 3, this is the third step. In the third step, once the ticket granting service role is over, by the time the session key will be established, next the client connects with the main server or Bob, which we are calling it as, using the encrypted key which has been given by the ticket granting service, and this key is temporary in nature. And this is how the whole thing proceeds. And finally, once everything is established, client finally connects with the final server, and the communication proceeds once the keys are known via encryption and decryption. So this is a brief overview. We have the user, here is the client, the user, here is the client. This is the server via which the user wants to connect, but before doing so, it uses two more servers, the authentication and the ticket granting server. What I'm doing is that I'm summarizing the process again. First, client does the authentication in the authentication server by using its user ID password, and the authentication server next tells the client that connect to the ticket granting server to get the session key, and for doing so it generates some key. I'll explain this more in detail in the next slide. Then the client requests the ticket granting server that give me the key. The ticket granting server gives the session key, the temporary session key, to the client, and the client then uses this to connect with the server or the main server for which the entire thing the client is doing, the main server. And then once the communication is established, they communicate using that particular key which is being generated in a secured way. By secured way, I mean to say encryption and decryption using this particular key that is being generated by the ticket granting server. So summarization: authentication server to authenticate the users, and ticket granting server to generate the temporary session key. And finally, this is the main server via which the connection is established between the client and the server. Now I'm explaining this entire process in more detail right now. Here we have the client, which we are calling it as Elise or user. This is the client, and this is the server, which we are calling it as Bob. So to communicate, we have the mediator, which we call it as KDC or the key distribution center. In case of KDC, in case of Kerberos servers, this KDC is made up of two servers, the authentication server and the ticket granting server. So what step I just told now, I'm again summarizing it here. The client requests for ticket, authenticates itself to the authentication server and tells that give me the ticket to connect with with the ticket granting server or TGS. Now the AS or the authentication server generates a key to Alice, which we call it as a Alice TGS session key for communicating with the TGS and the ticket for TGS. Now using this key, the client access TGS and tell TGS that give me a session key for, because I want to connect with the main server Bob. The TGS then generates a session key that will be used between Alice and Bob, and once this session key is used, the client informs the server like this is the session key is that I'll be using, I want to connect, and once the access is being granted by the server, secured communication then starts between the client and server using this key for encryption and decryption. Now this entire thing which I just talked right now, this is the process in more detail. I'm not reading out this text because it will not be clear unless the whole thing is explained diagrammatically. So first I'll explain the process diagrammatically and then I will come back to this textual description. So now let me go into more detail about how Kerberos works. I have given the introductory steps about the process, how it works. I'll go into more detail now. So we have the user or Alice, which we are calling it as the client, and we have the server, which we are calling it as the Bob. We have the authentication server and the TGS or the ticket granting server, and these two units in totality forms the KDC, which we also call as the K distribution center. Now, before I start with the algorithm, let me talk about the initialization part, some initializations that are done here. KAS, what is this? It is encryption. It refers to this symbol. Basically, it refers to encryption using the key between Alice and AS or authentication server. Now, this symbol, what does it mean? It refers to encryption using, this symbol refers to encryption using the key between TGS and Bob. This symbol refers to the encryption using the key between AS and TGS. Similarly, this symbol refers to the encryption between encryption done using the key between Alice and TGS, and this KAB refers to this whole thing. This whole symbol in totality refers to encryption done between Alice and Bob using the temporary session key that is being generated. Now, the point is the main aim is to get this key. To get this key, we'll be going through a number of processes, and this key is temporary in nature. That means it is meant only for that particular session to communicate. And other than this is fine. Now, before this, I'll just talk about what ATGS is. ATGS basically refers to the key, the session key that between Alice and TGS. What is TGS? We already said it is ticket granting service. AB refers to, AB with this symbol refers to the key between Alice and Bob, or the session key between Alice and Bob. We already said what is KDC. KDC stands for Key Distribution Center. AS stands for Authentication Server. TGS for Ticket Granting Server, and T for a timestamp or a noun. So with this initialization, now let us start with the main algorithm about how exactly the entire process works. So here we first, again I'm coming down here, the user or Alice here we are talking about is the client, and user wants to connect with the main server, which we call it as Bob. To do so, it has to go through a number of steps. Before connection, it needs the session key, because the session key will be used for encryption. For example, the client is connecting with the server, so it has to encrypt the message. So the session key is required, which we are calling it as a temporary session key. Similarly, from the server to the back to client, again decryption will be required, or whatever. Let me put it like this: client sends a message to let us say it will encrypt this message with a key K and send it to the server. The server has to decrypt this message again using the same key K. So the key K is required for secured communication between the client and the server. And what does Kerberos do? Kerberos talks about how to generate this key K that will be used for the purpose of encryption and decryption. And this key K, we are calling it as a shared temporary session key. So with this, we have this 6 steps that are involved in generation of this key, which you are calling it a session key, and this key will be subsequently used for encryption at the sender's end of a message and decryption at the receiver's end of the same message. So we are talking about right now how to generate this shared session key. Okay, let us start now. To start with, first step is Alice connects with the authentication server. How does it do so? It has to authenticate itself via the allocated user ID and password. So the first step is Alice gives its username and password and logs into the authentication server. Only if Alice is, or let us say only if, sorry, only if Alice, or let us say only if the client is an authenticated user, then only it will be allowed to proceed further. So once the authentication is being verified, the next step starts. Now, what is the second step? The second step, so in the second step, what the authentication server does is that authentication server now gives a key. What it does is that authentication server generates a key, because Alice needs key. To access the key, Alice has to connect with TGS, because only from TGS it has to get the key. So what the authentication server does, it gives a key. We all know what is as I explained, what is ATGS. ATGS is a key that will be shared between Alice and TGS, or it is a session key between Alice and TGS. So what the authentication server does is that it gives the key, it creates a ticket, and the ticket is made up of a key between Alice and TGS session, and a message and the name of the receiver, Alice. And this particular message block, or this particular ticket, it is encrypted using KASTGS. What is that? KASTGS is encrypted using Alice and TGS session key. So it is encrypted using Alice and TGS session key. And in addition to that, Alice, it also gives ATGS. What is ATGS? What is ATGS? ATGS, as I already explained, it is the Alice TGS session key. So I'm again summarizing. In step 2, what does the authentication server do? It gives a key that will be used between Alice and TGS, and then what it does, it also generates a ticket which will be sent for the TGS. For TGS, this is for Alice and this is for TGS, but it does not give directly to TGS, it gives it via Alice. And for TGS, what is written? What is given? The key and the message to TGS that it is Alice who wants to connect. And this particular message is encrypted using what? Using the key between Alice TGS. Now, once this message is received by Alice, it is encrypted using AAS, using KAS. What is it? Using the key between Alice and authentication server, which is already known to Alice. So Alice uses this key, which is already known, to generate this message, to get this message. Once this message is delivered, once this message is decrypted, and once Alice gets this message, Alice gets to know this particular value. What is this value? It is the key that will be used between Alice and TGS, and then Alice retrieves this. And in addition to that, the ticket which was meant to be transmitted to TGS, Alice sends it as it is to TGS. In addition to this particular ticket, Alice also sends a timestamp T for Bob, and this is encrypted using the key between ATGS, that is using the key between the authentication server and between the authentication server and TGS. Now, after TGS gets this message, what does TGS do? TGS decrypts this, because this is a message between the authentication server and Alice, decrypts this, and TGS gets to know the timestamp. And then what is this TGS? This is meant for TGS. TGS again decrypts this, and on decrypting this, how can it do so? Because this is done using the key between Alice and TGS. After decrypting this, authentication server gets to know, the TGS gets to know ATGS. What is ATGS? ATGS is the session key between Alice and TGS, and that the communication is done with Alice. Now, so the message has gone to the TGS server from Alice that I want to connect with Bob, and this is the key. Now what the TGS does, the next task of the TGS is to generate the session key. So TGS now generates a session key. As I told you, what is AB? This is the session key that will be generated, used between Alice and Bob. So TGS next generates a session key. This session key will be given, it's meant for both Alice and Bob, obviously, only then they will be able to communicate. So what the TGS does is that it creates two tickets. One is for Alice and the other one is for Bob. For Bob, it generates the session key and tells that yes, you'll be connecting with Alice, and it is encrypted using the key between TGS and Bob. That means Alice cannot decrypt this, it will be decrypted only by Bob. And for Alice, what does it do? It again generates the session key and tells that yes, you're connecting with the server Bob, and this is encrypted using the key between Alice and TGS. So when Alice gets this message, Alice can only decrypt this message. Why? Because the key here is the key that is used between Alice and TGS, which is already known to Alice, and this one cannot be decrypted because a different key is here used here. The key used here is the key between TGS and Bob. So Alice decrypts this message. Alice decrypts this message, and Alice keeps this message. After decrypting, Alice gets to know this particular AB, the shared key that will be used for communicating with Bob. And Alice then what does it do? It sends the ticket which is meant for Bob to Bob. In addition to that, it takes a timestamp T and encrypts it with the shared key that was generated AB. Now, server or Bob, when it gets the ticket sent by Alice, the encryption is done using the key between TGS and Bob. TGS and Bob, using TGS and Bob. So obviously Bob can decrypt it because this key is known to TGS and Bob. So Bob decrypts it, or the server decrypts it, and on decrypting, Bob gets to know the shared session key AB and also the message that the communication will be done with Alice. So by now, both of them have got the shared session key AB. Once the shared session key is being received, and in addition to that, using that shared session key which is being received, the server decrypts this message and gets to know the timestamp, because it is used for and for this device. So because this timestamp is encrypted using the session key AB, which was generated by TGS and given to Alice. So after this step, since T is known, to further authenticate itself, what does the server do? It decrements the timestamp by 1, encrypts it by the message AB, encrypts it by the key AB by now, which is also known to Bob, which is also known to Alice, and then sends it to Alice. Once Alice gets the message, it decrypts this again, because by now both of them, the sender and the receiver, or rather the client and the server, they know the value of AB, and then it checks that yes, I have sent a value T. Alice will find that yes, I have sent a value T and I've got a decremented value of T. That means this message is coming from an authentic server. That means this message I have actually communicated with Bob, and from now both of us are sharing the key AB. And from then on, what happens? For example, after this step, if Alice wants to, if Alice wants to communicate with, let me put it like this. If after this step, if Alice wants to communicate with Bob, so what? Let us Alice wants to send a message M with Bob. So what will Alice do? Alice will encrypt this message using what? The key AB, and then it will send to Bob. Bob, what will do once this message is received? Bob will decrypt the whole message which is being received, the encrypted message, using which key? Using the key AB. This is the subsequent step of communication. So the KERBEROS deals with how to establish the shared session key AB, and this is a detailed explanation of all the steps involved in KERBEROS. And let us to summarize more on this, we can say what are the advantages about this approaches. This approach, it is 100% free, it is open source, and it is used by many recent operating systems like Windows, Mac OS, Red Hat, Solaris, and so on. Drawbacks: KERBEROS requires the usage of the ability of, we need a central server, and if for a certain reason the server happens to fail, then the entire thing falls. Another drawback is that in order to issue a proper time-stamped ticket, synchronization is important, because if synchronization between the servers are not established, then things will also not work. So this is another point which is of concern. Some of the applications of this standard are, as mentioned before, KERBEROS is used as a software application that can be accessed through a terminal program. For Linux, we can use KERBEROS through terminal. For Windows, we can use KERBEROS through command prompt. And another point which is of concern for KERBEROS is that The developers have mentioned that this is meant for enterprise and professional use only. It can't be intended for individual home use. So, this is another point of concern. So, to conclude, we can say KERBEROS basically is a network authentication protocol that allows proper authentication between a server and a client. It is free and open source, and it is essentially a tool to provide optimum security to communicate between the server and the client. And how does it do? It does so by the establishment of a session key, which is temporary in nature, and that session key will be used between the client and the server for secured communication, and it is meant only for a certain session. And if more such communications are required, then the algorithm will be implemented for that number of times, equal to the number of times such communications will be required. So, these are the references which I have looked into for this topic. I have referred to Firozan, Cryptography and Network Security, and I also have taken up Stelling's book on Cryptography and Network Security Principles and Practices by William Stellings. So, thank you for now.